Welcome to 21st Century Learning. By the end of this video, you are expected to illustrate the different types of conic sections: parabola, ellipse, circle, hyperbola, and the degenerate cases. What is double knot right circular cone? When there are two lines intersect each other at a fixed point and at an angle in which one is fixed vertical line, when the line rotates around the fixed vertical line so that the angle remains same, we get a double knot right circular cone. Knot is the lateral surface or the round surface of the cone. The cone above the vertex is called the upper knot, and the cone below the vertex is called the lower knot. The fixed vertical line here is called the axis. The line which is rotating is called the generator. The fixed angle is called vertex angle. The intersection point of two lines is called vertex. The vertex divides the cone into naps. Now, let's dive in deeper to our discussion. When the plane intersects with the double right circular cone in such a way that the angle between the axis and the plane is equal to 90 degrees, the section is called circle. When the angle between the axis and the plane is equal to the vertex angle, we get an open curve called parabola at the intersecting surface of the cone. When the plane intersects with the double right circular cone in such a way that the angle between the axis and the plane is greater than the vertex angle, then an ellipse is formed. When the plane between the angle and the axis is less than the vertical angle, then the plane intersects both the naps of the cone, which forms two disjoint open curves that are called hyperbola. Again, what are the four types of conic sections? Circle, parabola, ellipse, and hyperbola. Great! These are called a conic section because these are formed by the intersection of a plane and a cone. Conic, as these are made out of a right circular cone, and section, as these are the sections or the pieces of a cone. Now, what happens when the plane intersects the double right circular cone at the vertex? Circle and ellipse becomes a point. Parabola becomes a straight line. And hyperbola becomes a pair of intersecting lines. These are called the degenerate conics. Welcome to the continuation of our discussion. At the end of this video, you are expected to define a circle. What is a circle? In conic section, circle is formed when the plane intersects the double right circular cone horizontally perpendicular to the axis. The general equation of any conic section is given by ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, c, d, e, and f are all constant. But what really is a circle, and how do we determine the equation of a circle? To answer your question, come with me and let's find it together. A circle is defined by its center and the radius. The radius is a line segment from any point on the circle to the center. We name a circle based on the letter assigned to its center. In the given example, we have circle C, with line segment CP as the radius. The derivation of the equation of the circle is by the use of distance formula. D equals the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. We make use of point C and point P in this example, where C is the center of the circle and P is any point on the circle. To get the distance between the line segment CP, we simply substitute the value to the given formula. Remember that line segment CP is our radius, thus, we can simply make use of r. To remove the square root sign on the right side of the equation, we need to square both sides. This is not to violate the rules of equality. Hence, the standard equation of the circle is r squared equals the quantity of x minus h squared plus the quantity of y minus k squared. Or, we can also say that the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. To further understand the lesson, let us have examples. Determine the standard equation of the circle, then show the graph in a Cartesian plane. Since the center is at the origin, the coordinate of the point is 0, 0. Simply substitute the value to the given equation. We have 4 squared equals the quantity of x minus 0 squared plus the quantity of y minus 0 squared. Hence, 16 equals x squared plus y squared, or x squared plus y squared equals 16. To graph the equation, locate the center first. Since our radius is 4, so from the center, plot the point 4 units to the right, 4 units to the left, 4 units below it, and 4 units above it. Then, connect the outer points in circular pattern. Great! There you have it. Now, let's proceed to another example. Our C is 3, 4 with R equals 2. Same with the previous examples, all you have to do is simply substitute the value to the given equation. Thus, 2 squared equals the quantity of x minus 3 squared plus the quantity of y minus 4 squared. Hence, 4 equals the quantity of x minus 3 squared plus the quantity of y minus 4 squared, or the quantity of x minus 3 squared plus the quantity of y minus 4 squared equals 4. To graph the equation, locate the center. From the center, plot a point 2 units to the right, 2 units to the left, 2 units below it, and 2 units above it. Then, again and again, connect the outer points in circular pattern. There you go, you have another circle. Good job! Now, what if you are given an equation? Can you identify the center and radius? How about a graph? Can you determine the equation? Oh, it's for you to find out. See you in the next release of my video. Bye!